A bridge to ponder. Have you ever wondered how the iconic Brooklyn Bridge, one of the oldest roadway bridges in the United States, was designed and built? This marvel of human ingenuity stands as a testament to the power of civil engineering. Born from the mind of John Augustus Roebling in the late 19th century, it was built to connect the bustling boroughs of Manhattan and Brooklyn. It took 14 long years to complete this architectural masterpiece. Let us delve into the fascinating details of the design process of this architectural marvel. The mastermind behind the design. The Brooklyn Bridge was not a product of chance, but a result of meticulous planning and design by a renowned civil engineer. This maestro of civil engineering was none than John A. Roebling. A man with a rich background, Roebling was a Prussian immigrant with a degree in engineering from the Royal Polytechnic Institute of Berlin. His vision: to construct a bridge that would not only connect Brooklyn to Manhattan, but also stand as a symbol of unity and progress. Was no stranger to, he had already established his reputation with the successful completion of several suspension bridges across the United States. Experiences and deep understanding of suspension bridge design strongly influenced his vision for the Brooklyn Bridge. Envisioned a structure that was both functional and aesthetically pleasing. A bridge that would withstand the test of time. With a clear vision, Roebling embarked on a journey to create an engineering masterpiece. The design process unveiled. Designing a bridge of such magnitude in the 19th century was no easy task. The Brooklyn Bridge, an architectural marvel of its time, required meticulous planning, innovative techniques, and robust materials to bring its design to life. The first challenge was planning the bridge's length. Spanning almost 1,600 feet, it was to be the longest suspension bridge in the world. This called for a design that could withstand immense pressure while stability. Next came the materials. Stone, cement, and timber were commonly used in the 19th century, but the bridge's design called for something stronger and more durable. Enter steel, a material that was still relatively new to the construction industry. Its strength and flexibility made it ideal for the bridge's main structure and cables. The suspension cables, in particular, were a feat of engineering. Each cable was made up of thousands of individual steel wires tightly wound together to create a single, incredibly strong strand. This was a novel concept at the time, as most bridges relied on iron chains for suspension. But for the Brooklyn Bridge, steel was the material of choice. The bridge's towers, each standing at a height of over 270 feet, were also an engineering marvel. Built from limestone, granite, and Rosendale cement, they were designed to bear the weight of the entire bridge. The use of caissons, large watertight chambers, allowed workers to excavate the riverbed for the tower's foundations, another innovative technique of the era. The design process was not without its challenges. From dealing with the unpredictable river currents to perfecting the tension in the suspension cables, each step required precise calculations and careful execution. The weather, too, was a constant adversary, with harsh winters and sweltering summers slowing down progress. But despite these obstacles, the design of the Brooklyn Bridge came together. It was a blend of determination, innovation, and engineering prowess that turned a daunting task into a feasible blueprint. Despite numerous challenges, the design was ready, paving the way for the construction phase. Construction and challenges. The construction of the Brooklyn Bridge was a test of human endurance and engineering prowess. It was a colossal undertaking that pushed the boundaries of what was deemed possible in the late 19th century. A major part of the construction involved the use of caissons. These were large watertight structures that allowed workers to lay the bridge's foundation deep underwater. This was a groundbreaking technique at the time, and the caissons for the Brooklyn Bridge were the largest ever constructed. Workers would descend into the depths of the East River, chipping away at the riverbed to make way for the bridge's two stone towers. However, the use of caissons was not without its challenges. The most significant of these was a mysterious ailment that afflicted many of the workers. Known as caisson disease, this condition was caused by the rapid change in pressure as workers ascended from the depths of the caisson. Symptoms included severe joint pain, paralysis, and in some cases, death. Today we know this condition as decompression sickness, or the bends. Despite these challenges, work on the Brooklyn Bridge continued. The workers, known as sandhogs, showed incredible resilience in the face of adversity. They toiled away in difficult conditions, chipping away at the riverbed and laying the foundations for what would become one of the world's most famous bridges. In addition to the physical challenges, the project also faced numerous logistical and financial hurdles. Yet the team behind the Brooklyn Bridge persisted. They overcame each obstacle with a combination of ingenuity, determination, and sheer force of will. The construction of the Brooklyn Bridge was a monumental effort that tested the limits of engineering and human endurance. But through it all, the workers and engineers remained undeterred. Their perseverance and dedication to the task at hand is a testament to the indomitable spirit of humanity. After 14 long years of perseverance, the construction phase was completed. The Brooklyn Bridge stood as a testament to what can be achieved through determination, innovation, and a little bit of grit. The finalization and legacy. On May 24, 1883, the Brooklyn Bridge was finally opened to the public. A moment etched in history, marking the end of a 14-year-long journey of grit, determination, and groundbreaking civil engineering. The bridge's grand inauguration saw an estimated 150,000 people crossing it the very first day. This marvel of civil engineering didn't just connect the boroughs of Manhattan and Brooklyn physically, but also brought them together in a newfound spirit of unity. It opened up new avenues for trade, commerce, and cultural exchange, forever altering the fabric of New York City. The Brooklyn Bridge, however, is not just a functional construct. It's a symbol of human perseverance, of our relentless pursuit of the seemingly impossible. It stands tall, reminding us of the power of imagination and the strength of will, inspiring countless civil engineers and architects worldwide. But the legacy of the Brooklyn Bridge extends beyond its physical. It's in the lessons it imparts to every civil engineering student: the importance of meticulous planning, the value of rigorous testing, and the courage to innovate. It's a living lecture, a case study in civil engineering that continues to inform and inspire. Today, the Brooklyn Bridge is not just a bridge. It's a monument, an icon, a testament to the indomitable human spirit. The Brooklyn Bridge stands as a testament to human ingenuity and the power of civil engineering, connecting not just two boroughs, but also generations of awe-inspired observers. Subscribe if you want to learn more about architecture and engineering.